Hi everybody. So in this video we're going to look at how to solve trigonometric equations using the T-formulae. So this is the third video in this series. In the previous videos we learned how to prove the T-formulae and how to use them with trigonometric identities. So in example 1, using T-formulae, solve the equation sine theta equals 2 cos theta within the range for theta between negative 180 and positive 180. So the first thing we're going to do is we're going to say let t equal tan of theta over 2. And this means we can write the sine of theta as 2t over 1 plus t squared and cos theta as 1 minus t squared over 1 plus t squared. So these are the standard formulae for sine and cos theta. So now we have these, we can substitute them into our equation. So we have sine theta is equal to 2 times cos theta. And you can see that we can divide both sides of this equation by 2, cancel this and this 2 out, and we can multiply both sides by 1 plus t squared. So this will cancel with this one. So now we have t is equal to 1 minus t squared. And we can solve this quadratic by making it equal to 0. So therefore, t squared plus t minus 1 will equal 0. Now this doesn't factorise, but we can use the quadratic formula, and we get t will equal negative 1 plus or minus the square root of 5, all divided by 2. You can also work this out on your calculators. So now we've got a value for t, we can substitute tan of theta over 2 back in place of t, so now we'll have two solutions. The tan of theta over 2 will be the positive case. We can take the arctan of both sides, so theta over 2 will be 31.7, and tan of theta over 2 will be the negative case. We can take the arctan of both sides, so theta will be negative 58.28 degrees. So we have our values for theta over 2, but the question asks to find theta, and this is in the range of negative 180 to positive 180. So we need to change this range to match our solution. So we divide everything by 2, so now theta over 2 is in the range of 90 to negative 90. And if we use our cast diagram, there are no other solutions here, because if we go beyond this quadrant, we go outside of our range. And for the negative solution, if we go beyond this quadrant, again we go out of our range on this side. So our solutions are when theta over 2 equals 31.7 and negative 58.3. So to work out theta, we need to multiply both sides by 2. So our solutions are theta is 63.4 and theta equals negative 116.6. Okay? So in example 2, we're going to look at a slightly more complicated equation. Okay, so in example 2, using the substitution that t equals tan of theta over 2, shown that this equation can be written in this form, and then we're going to use this form of the equation to solve the original in the range of negative pi to pi. So because we know that t is tan of theta over 2, we can use the standard formulae for cos theta and for sine theta, and we can substitute each of these into the original equation. So we have 5 lots of cos theta minus 2 sine theta equals 2. And we can see we've got a common denominator of 1 plus t squared. So we can write all of this over this common denominator and then move that to the right hand side. And we can expand out the pairs of brackets. So we've got 5 minus 5t squared, expanding out in this bracket, minus 2 lots of 2t, gives us negative 4t. And the common denominator we've moved to the right hand side. Now we can expand this out, and then we can move all the terms over to the right hand side, because then this will become a positive 7t squared. And now we have our quadratic equation. So this is part A. And for part B, to solve the equation, well, we can solve this by factorising. So we get 17 minus 3 multiplied by t plus 1 equal to 0. We can make each bracket equal 0, so we get t equals 3 over 7, and t is negative 1. And then we know that t is the tan of theta over 2. So these become our solutions to theta over 2. So if tan of theta over 2 is 3/7, we can take the arctan of both sides. So theta over 2 will be 0.405 radians. Also, if tan of theta over 2 is negative 1, using this solution, we'll take the arctan of both sides. So we get theta over 2 is negative pi over 4. So in the question, we've been given the range for theta, but now we have theta over 2. So we need to change this range by dividing the negative pi, theta and pi, all by 2. And within this range, the only solutions are the ones we've already found. So if this is theta over 2, we can find theta by multiplying both sides by 2. So theta is 0.81 radians and negative pi over 2 radians. Okay, so thank you very much for watching, and I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.